Okay, so let's look at a few more examples of regular expressions. The next example that I showed in class was if we're given this alphabet AB, we have the following regular expression R, which is A or B whole star, AB, A or B whole star. So what is the pattern that this regular expression is matching? What strings match this pattern, rather? Well, take any string in sigma star. What this regular expression R is saying is for X to match with R, X has to start with any number of A's or B's in any sequence, right, in any order. That's exactly what this guy is telling us. Then I have to have this sequence of symbols or letters AB, right? And then after that, I can have any number of A's and B's in any sequence, right? So this thing here tells me I can have any number of A's or B's before this AB. This thing here tells me I can have any number of A's or B's after this AB. And so what really effectively this is saying is that any string that matches this pattern must contain the substring AB. Okay. Good, okay. So that's another example of a regular expression. In this case, this was also a language for which we had created a DFA, I think it was. And so again, you can see that the regular expression is a more sort of user-friendly way of talking about the regular language, right? Okay. Now, what happens if we sort of flip this problem and we ask ourselves, how can we create a regular expression R such that the language recognized or described by R is, for instance, in this case, strings of the alphabet 0, 1, for which those strings have an odd number of ones. Okay, so I want to create a regular expression R that is going to match strings with an odd number of ones and only strings with an odd number of ones. Well, this is kind of a different problem-solving technique. It's slightly different than when you were creating FAs. When you were creating FAs, you were trying to think of sort of the roles that each states were playing and how can you sort of most compactly create a machine where you don't have any redundancy in the states such that you can accept the strings that you want to accept and reject the strings that you want to reject. Okay, so it's a slightly different technique when you're designing regular expressions because now you really want to analyze the strings in the language you want to describe, and you want to see what rules underlie these strings and how can you translate those rules into regular expressions. So in other words, with only the regular expression operators. And the regular expression operators that we're only allowed to use in this case are this star operator, the plus operator or the or operator, and also the concat operator. Okay. So let's consider some arbitrary string in this language here. What must that string look like? Well, we know that this string has an odd number of ones. So if it has an odd number of ones, really what this means is it has pairs of ones, right? It has pairs of ones, and then at some point it has one extra lonely one, okay? So that's exactly what I'm going to describe here. I'm going to say that in my string X, I have pairings of ones, so this one is paired with this one. And then it doesn't really matter, I could have zeros in between, zeros to the left, and zeros to the right. Okay. And then again, maybe I have an extra pairing of ones, so maybe I have again, this one is paired with this one, and in between I have some zeros, to the left I have some zeros, and to the right I have some more zeros. And so we see that this general pattern can be repeated any number of times. And so that's exactly what we're going to write down here. We're going to say that if I have a 1, it's paired with another 1. Then I can have zeros in the middle, to the left, and to the right. And this pattern can occur any number of times. But now, because I have to have an odd number of ones, right, I need to have this extra singleton one, this extra lonely one. And so this extra lonely one is going to be here. It's going to be all alone, so it's not going to have any ones as friends, but it could have zeros to the left and zeros to the right, because that doesn't affect the parity of the number of ones, right? And so effectively what that means is that I have 0 star, 1, 0 star here. Okay. And someone had actually asked during class, well, this seems slightly redundant. Why can't we have something like this pattern and then concatenated with 1, 0 star? Well, you can't quite do that. You can't quite do that because if you did, then you wouldn't be able to recognize a string that looked like this, with a bunch of zeros and then a 1 and then a bunch of zeros. Okay? However, there is some redundancy, and this is actually one of the only new things I might add to the notes. There is some redundancy, so some redundancy exists. And that redundancy is this extra 0 star. So this extra 0 star, actually a very bright student pointed this out to me, is that this 0 star isn't really technically necessary because you can either compensate with its absence by the 0 star here if I have more pairings of 1s, or I can compensate with this 0 star here if that was the last pair of 1s. And so I could have also written 0 star 1, 0 star 1, whole star, and then 0 star 1, 0 star. Okay, so convince yourself that this is equivalent just by looking again at an arbitrary string and seeing that it can also satisfy this type of pattern.